In this video, I'm going to show you some more examples of questions related to finding determinant of a matrix. The first question is, find the value of lambda such that this determinant lambda 2, 3, lambda plus 4 be equal to negative 1. We want to find the value of lambda such that the value of this determinant be equal to negative 1. Let me remind you, when we have a 2 by 2 determinant, like a, b, c, d, we can find this determinant from this formula, a times d minus b times c. A times d minus b times c. Based on this formula, this determinant is lambda times by lambda plus 4, a times d minus b times c, 2 times 3, which is 6, and this should be equal to negative 1. If we multiply lambda in the bracket, we have lambda squared plus 4 lambda minus 6 equals negative 1, which now if we bring negative 1 to the left side, we get to this quadratic equation. We can factor this in the form of lambda plus 5 times lambda minus 1 equals 0. Note that 5 times negative 1 is negative 5, and 5 plus negative 1 is positive 4. From this, we can find lambda is negative 5. We have to set this equals 0, and if we set the other bracket equals 0, lambda is 1. So the values of lambda that make this equal to negative 1 are negative 5 and positive 1. Let me show you another example. These two matrices are given 2, 3, negative 5, 1, and matrix B is negative 1, 0, 4, and 3. And we are asked to find these values. The first question is to find determinant of matrix A plus B. So we have to add matrix A to the matrix B, and then we have to find determinant of that matrix. Note that you cannot say that this determinant of A plus B equals determinant of A plus determinant of B. We don't have such property for determinant of the sum of two matrices. So you are not allowed to use that relation. We don't have such relation in the determinant of the sum of two matrices. First, we have to add A to the B, and then we have to find determinant of that matrix. So, A plus B is this matrix. This is a 2 by 2 matrix, and this is a 2 by 2, so we can find the sum of them. And for finding A plus B, we have to add the corresponding elements. 2 plus negative 1 is 1. 3 plus 0 is 3. Negative 5 plus 4 is negative 1. And 1 plus 3 is 4. Now we have to find determinant of this matrix. Note the difference between notation for matrix and determinant. When we want to find determinant of a matrix, we put vertical lines like this. This is the notation for determinant of a matrix. But this is actually right now a matrix, not a determinant. So for finding determinant of this matrix, we can use this notation here. So we can say determinant of A plus B equals to 1 times 4, which is 4, minus 3 times negative 1 is negative 3. 4 minus negative 3 is 7. The other notation that we can use for determinant of a matrix is this notation. Determinant, we show it with vertical lines like this, 1, 3, negative 1, 4, and this equals the same thing. 1 times 4 is 4 minus negative 3, which equals 7. So again, it's important to know the difference between these notation. This is just a number, as you can see, but this is an array of numbers. This is a bunch of numbers. So it's important to notice to the notations in mathematics. When you have a square brackets like this, it's a matrix, but this is just a number, as you can see. There is no difference between these and just this number. The next question here is find determinant of A transpose minus B transpose. So first we have to find the transpose of matrix A, the transpose of matrix B. We have to subtract them, and then we have to find the determinant of that matrix. The transpose of the matrix A is 2, 3, negative 5, 1. Remember that for finding the transpose of a matrix, we have to make the rows of that matrix the columns for the transpose. When we transpose a matrix, we change the rows to the columns. 2, 3 here is a row, we make it a column here. Negative 5, 1 is a row, we can make it the second column. So it's easy to find the transpose of a matrix. But if you are not familiar with the transpose of a matrix, you can watch my video regarding the transpose of matrices. And the transpose of the matrix B is make the first row, which is negative 1, 0, the first column here, and make the next row the next column. So 4, 3 is B transpose. Now we have to subtract A transpose from B transpose from A transpose. So AT minus BT is this matrix. A transpose minus B transpose is 2 minus 1 is actually 2 plus 1, which becomes 3. Minus 5 minus 4, or that we are subtracting the two matrices, is minus 9. 3 minus 0 is 3. 1 minus 3 is negative 2. Now we have to find determinant of this matrix. Determinant of A transpose minus B transpose is 3 times negative 2, which is negative 6, minus negative 9 times 3 is negative 27. Minus 6 plus 27 is 21. In this question, we have a 3 by 3 determinant. 2, negative 1, 3, x, 0, 1, 1, 1, negative 2, and we want to find the value of x that this determinant is equal 0. Note that here we have a determinant because here we have vertical lines. This is not a matrix. This is the determinant of a matrix. And we want to find the value of x that makes this determinant equal 0. First, let me remind you the formula of finding a 3 by 3 determinant. If you have a determinant in the form of a, b, c, d, e, f, g, h, I, determinant of such a matrix is a times by this value, the first element, times by determinant of this part of the matrix, determinant of E, F, H, I. This part, this sub-matrix of the original matrix. We eliminate this row and this column, and then we get to this determinant. Then we have to go to the next number, negative b times by determinant of deleting the first row and second column. What remains is d, f, g, I. And then finally plus c times by determinant of this part, because we have to delete the first row and the third column, d, e, g, h. If you want to learn more about determinant of 3 by 3 matrix, watch my video regarding finding determinant of 3 by 3 matrices. In that video, I explained in more detail this formula. Based on this formula, this determinant is equal to 2 times by determinant of deleting this row and this column. What remains is 0, 1, 1, negative 2. Then we go to the next element, minus b, minus 1, so that minus negative 1, which you can make it positive 1, times by determinant of deleting this row and column, x, 1, 1, negative 2. And finally, plus 3 times by delete this row and this column, x, 0, 1, 1. And finally set this equal to 0. Here we have a 2 by 2 determinant, which we know this equals 0 times negative 2 is 0 minus 1. So this determinant is simply negative 1. Here we have positive 1, which is not necessary to put 1, but if you like, you can put 1 here. This determinant is negative 2x minus 1. And finally, we have 3 times by x minus 0. So we have only x equal 0. Now for solving this equation, note that 3x minus 2x is x, minus 2 minus 1 is minus 3 equals 0. So finally x is 3. Let me show you one more example of 3 by 3 matrices. Determinant of a 3 by 3 matrices. We want to find determinant of this matrix. Sine of theta, cosine theta, 0, cosine theta, negative cosine theta actually, sine theta, 0, sine theta minus cosine theta is the next entry of this matrix, sine theta plus cosine theta, and the last entry is 1. We want to find this determinant. If we use the formula for finding the determinant of a 3 by 3 matrix, we have sine theta, the first element, times by determinant of this part, determinant of sine theta, 0, sine theta plus cosine theta, 1, minus, don't forget this minus, this is a common mistake between the students, they forget this sign, minus cosine theta minus this element times by determinant of deleting first row and second column. What remains is negative cosine theta, 0, sine theta minus cosine theta, and 1 here. Finally, we have this. Because that entry, that element is 0, it's not necessary to write this, because 0 times by anything is 0. But let me write this determinant. We have to delete the first row and the third column. What remains is negative cosine theta, sine theta, and here we have sine theta minus cosine theta, and the last element is sine theta plus cosine theta. But note that again this part is 0. Here we have sine theta times by a sine theta. 0 times this is 0, so sine theta times sine theta, minus cosine theta times by this times this is negative cosine, and 0 times this is 0. So we have only minus cosine theta. And all of this is 0. So here we have sine squared theta plus cosine squared theta. Sine squared plus cosine squared from one of the trig identities is 1. So the determinant of this 3 by 3 matrix is 1. I hope by watching this video you have learned a bit about finding determinant of 2 by 2 or 3 by 3 matrices. If you like this video, please subscribe in my channel, and thank you for watching.